Okay, welcome to Unit 5, cubic functions. So we're going to start off by introducing the cubic function and what it looks like. And we're going to plug in a -3 into our cube function. So it's going to take the -3 and cube it. -3 times -3 is +9 times another -3 is -27. And likewise, we'll finish the rest of our graph, our table here. Obviously, we can't graph -327 on our little graph. We can start with -2, -8. -1, -1, 0, 0, 1, 1, and 2, 8. Kind of missed that point. And it continues upwards and downwards. So some of our characteristics that we always want to take a look at: x-intercept. It goes through the origin, so our x-intercept is 0, 0. Likewise, y-intercept is 0, 0. Our domain, in this case, it continues. We can put in any negative value. We can put in any positive value. So the domain is all real numbers. And we could write that, if we want, in interval notation with -infinity to +infinity. Our range is a little different than the quadratics we've been looking at. It continues going downwards and upwards. There's no limit. So again, our range is all real numbers. And we could put it in the interval notation or in our inequality notation. So -infinity is less than y, which is less than +infinity. Any one of these notations is fine. A vertex. This does not have a vertex. So we're just going to say none. Relative minimum and relative maximum. We don't see this on the parent function, but as we progress to the notes, we will see this. And symmetry. This is not symmetrical if we reflect it, either across the x or y axis, but it is symmetrical if we were to rotate it. So if we took our page and rotated it 180 degrees, it is symmetrical. So it's a rotational. So 180 degrees, rotational symmetry. Inflection point is the point that we're going to use when we move or translate our parent function. And in this case, it is at 0, 0. That's the point we're going to track to see how it has been translated or transformed. We have two equations here that we will use for our transformations. Our cubic transformation form is of the form a multiplied by b, parentheses, x minus c, close parentheses, cubed plus d. We also have a standard form which looks a lot like the quadratic standard form. However, it's important to keep in mind that a, b, c, and d are not the same in both these forms. So don't make the mistake of assuming if it's a value of 4 for c here, it's going to be a 4 here. That will not hold true. Okay, let's take a look at our cubic transformation, what happens here. In the past, we saw that the a value will cause a vertical stretch, vertical compression, and we also can see a reflection if a was less than 1, or less than 0, excuse me. Vertical stretch, we got that if the absolute value of a is greater than 1. Vertical compression if the absolute value of a is less than 1. B causes the parent function to have a horizontal stretch or horizontal compression. And it's by a scale factor of 1 over b. 1 over b here. We will investigate that a little bit more in tomorrow's class. C causes the parent function to translate horizontally. So we either go to the right or to the left. We go to the right if the C value is positive. We go to the left if the C value is negative. Of course, it will look the opposite in the equation because we have a minus sign in there. D causes us to translate vertically. So to go up if D is positive, to go downwards if D is negative. So now if we're just going to describe these transformations. The 2 on the outside is the equivalent to the A. because remember, a doesn't get cubed, whereas b does get cubed. So this is an a value. It's greater than 1, so we are vertically stretched by 2. We went right by 1 and up by 3. Second function, again, that's an a value. It's greater than 1, so we know it's a vertical stretch by that value, 4. We have a positive 5 in the equation, so that tells us we've gone to the left by 5 and down by 3. Okay, and see, we've got to start off with a negative, so we know that's a reflection. The 2 is a vertical stretch by 2. The 4 here tells us we've gone to the right by 4 and down by 6. Four translations there. On D, the 1/3 tells us it's a vertical compression by 1/3, and we've gone to the left by 5. In E, we've got a reflection. Remember, we reflect across the x-axis on these guys, and x minus 1 cubed tells us that we have moved to the right by 1. Letter F, we have a cubic that has moved to the left by 2 and down by 2. A nice simple one there. And our final one on this page, we've got a vertical compression by 1/2. Remember, that gives the appearance of looking wider. It's been compressed from the top and the bottom. And it's moved upwards by 1. Okay. Now we're going to just take a look at some values A, B, and C. I'm sorry, A, C, and D. So we've got to look for that inflection point. So our slope changes here. So our slope's been getting positive, flattens out here, and then comes back up. So this point is at 2, 1. So that's my value for C and D. 2, positive 1. And let's throw in A just so we get a little bit of practice here. Just like in the quadratic, we're going to look at what would happen if we step over 1 from the inflection. Our parent function goes up 1. Sure enough, we go up 1 here also. So A value is just 1. Now our equation is going to be y equals our A value of 1, B value, there is no change here, we're not looking at that today, x minus 2 cubed plus 1. Our second one, our inflection point is at negative 1, and we're down at negative 4. So our C value is negative 1, D is negative 4, and we'll just confirm our A value. If we stepped over 1, we go up 1 before we hit our function. So that's also still a 1 value. Our cube function will look like y is equal to 1 x plus 1, because this is really x minus a negative 1, which becomes a positive, cubed minus 4. And some of you may ask, do you have to write that 1? Of course not. I'm just putting that in to illustrate where it goes. Okay, and our final one, our inflection point is at negative 2, positive 3. And our A value, if we take a look, step over 1, up 1. So we're still dealing with no stretch or compressions. So I'm going to omit the 1 this time. So x minus a negative 2 becomes x plus 2 cubed plus 3 to demonstrate. Okay, and our final page. We're going to take a look at factors. How do we create our cubic equations? And one thing to keep in mind here is, if you remember with our quadratics, we solved for x But we can go the opposite direction. We can take our solutions, our x-intercepts, and work backwards to create our factors. And then we multiply those together to get the cubic function. So if we want to multiply these guys together, I've got 3 different binomials. We'll start with taking any 2 of them and multiply them together. It does not matter which ones you take. So I'm going to do x plus 2, and I'm using the box method, and 3x minus 2. Once we get the result of this, we will then multiply it by the binomial we have not used. So 3 times x is 3x squared, x times negative 2 is negative 2x, 3x times 2 gives us 6x, and 2 times a negative 2 is negative 4. So when we combine these guys, we have 3x squared, 6x minus 2x is a positive 4x, and minus 4. So we're now going to take this trinomial and multiply it by the 4 plus x. So we need a bigger box this time, because we've got 3 terms. And it doesn't matter if I do my 3 as rows or as columns. So we've got 3x squared plus 4x minus 4 multiplied by 4 plus x. Don't let this order disturb you. You could have put the x plus 4 if that looks more familiar. We now are multiplying everything on the left times the item on the top. So 3x squared times 4 is 12x cubed. 3x squared times x is 3x. Oops, this was squared. 4, not 4x. 4 times 12x squared gives us 12x squared. 3x squared times x gives us 3x cubed. 4x times 4 is 16x. 4x times x squared is 4x squared. And 4 times negative 4 is negative 16. Negative 4 times x is negative 4x. We now are going to combine all those terms to write out our full equation. So y is equal to 3x cubed. Now our x squared, so we've got 12x squared plus a 4x squared gives us 16x squared. And 16x minus 4x gives us minus 12x minus 16. So this cube is the same as the cube you'd get from these 3 linear factors. Okay, let's do another one. So again, it does not matter which ones we start with. I'm going to use this linear factor that would be 3x plus 0, which we don't write, as it's a smaller box to create in the beginning. So we're going to have 3x, and let's multiply it by the 5x plus 7 here. So 3x times 5x gives me 15x squared. 3x times 7 is 21x. So I'm now going to take this binomial and multiply it by the 10x plus 2. This time we get another 2 by 2 box, and we have 15x squared plus 21x multiplied by the 10x plus 2. So 15x squared times 10x gives us 150x cubed. 15x squared times 2 gives us 30x squared. 10x times 21x gives us 210x squared. And 2 times 21x is a positive 42x. Okay, so let's write this out, combining like terms. We've got y is equal to 150x cubed plus, we've got a 30x squared plus a 210x squared. So that gives us 240x squared plus 42x. And notice I don't have a final value, a d value here. Perfectly okay. And that is my cubic function. Okay, our next example, we've got a linear term multiplied by a quadratic. So if I were to multiply these, I'm going to need a 2 by 3 box. I'll make it nice and big so that hopefully you can read my writing. So So I've got my x. Make sure you keep that sign with the 6, negative 6, multiplied by 2x squared minus 3x plus 1. 2x squared times x gives me a 2x cubed. X times negative 3x is a negative 3x squared, and x times 1 is just x. Negative 6 times 2x squared is a negative 12x squared. Negative 6 times a negative 3x is a positive 18x. And finally, negative 6 times a positive 1 is negative 6. We combine our like terms, and we're going to get y is equal to 2x to the third. So we've used that term. Negative 12x minus 3x squared. We could add those together and keep the sign. So we have a negative 15x squared. And we have an 18x plus an x. That gives us 19x and minus 6. There's our cube function formed from our linear term and our quadratic. And finally, we could take a look at these three lines, so they're linear, and look at what our x-intercepts are. So my first x-intercept is at x equals a negative 2. Second line gives us an x-intercept of x equal to negative 1. And our third one is at x equals a positive 3. And like I mentioned previously, we can discover our factors by working backwards. Set each one of these equal to 0. So I have to add my 2, so I get x, plus 2 here equals 0. This one would give me x plus 1 equals 0. And this one, when we subtract the 3, we have x minus 3 equals 0. At this point now, I have my factors of this quadratic. So I can multiply them all together to find the cubic equation. So I'm going to take x plus 2 times x plus 1. This time I'm just going to FOIL it, I'm running out of space. So x times x gives me x squared. X times 1 is a plus x. 2 times x, there's an x there, plus 2x, and 2 times 1 is plus 2. So that's x squared plus 3x plus 2. And I still need to multiply it by my third factor, the x minus 3. So let's do our box here. Which one? I guess we'll go this way. So we put our x, the negative 3, and here I have x squared, 3x, and 2. So we get x cubed minus 3x squared, 3x squared, minus 9x, plus 2x, minus 6. So we write out our final cubic equation formed from our three linear x-intercepts. And we get x cubed. Oh, look at that. Our x squareds cancel with each other. That's kind of nice. So 2x minus 9x gives us a negative 7x minus 6. Now, if we were to plug this into our calculator to get a graphic view, a way to check this would be to plug into y equals each one of our factors multiplied together. So I'm just going to put this here. Let's clear that out. So we will put x plus 2 times x plus 1 times x minus 3. One of the ways to double check ourselves that we've done everything correctly is now for y2, let's plug in the equation that we found it to be, minus 7x minus 6. If we go to our graph, and I've modified my graph a little bit. Sure enough, it's graphing right over the top, so that's good. They're the exact same. But also the thing I wanted you to notice is look at these 2 points right here. These are what are called our relative max, because in that area, that's the maximum point. And this one over here is our relative minimum, because it's at the bottom in this area of our curve. So we have a relative max and a relative min when we graph this guy. Okay, thank you. Enjoy your homework. Well, it does not seem to want to end.